Hey guys, my name is Trevor Sullivan. Welcome back to my video channel. I know it's been a while since I've done a video on the Rust programming language, but I actually got a comment on one of my videos from a while back, my Rust programming tutorial video series, where the viewer asked if I could do a tutorial on how to do data validation with the clap crate for Rust. Now, if you recall from a while back on my channel, I actually have a video that talks about how to implement command line arguments using the clap crate. And there's a couple of different patterns that you can use. There's what's called the builder pattern and the derive pattern. Generally, I prefer to use the builder pattern. It just kind of makes more sense to me. But if you prefer to use the more declarative approach, you can also use that derive pattern. But yeah, that video was done quite some time ago. And I apparently had mentioned at the beginning of the video that you could do data validation, but never actually demonstrated how to accomplish data validation. So that's what we're going to be focused on in this particular video. So a lot has changed in the Rust ecosystem. I mean, a lot has, but it also at the same time hasn't. It's still pretty stable. So not a ton has changed, but there definitely have been a lot of like small feature improvements coming out lately. I think it was just earlier today, actually, that Rust 1.85.0 has been released. So, as usual, make sure that you're running the latest version of the Rust toolchain. Of course, you can get over to the website at rustup.rs. This is where you can install the RustUp installer on your system. And then once you have the RustUp installer, then you can actually install different versions of the tool chain. So you can install the stable tool chain, you can install the beta, you can install the nightly, and for different architectures as well. So go to rustup.rs if you don't already have the Rust tool chain installed. Make sure that you use this approach. There are alternatives out there to installing the Rust tool chain, but by far the community by consensus agrees that using the RustUp official installer here is the right way to go, regardless of what platform you're on. Also, the other option is to just build a Rust environment by spinning up a new Rust Docker container. There are official container images out there that are very regularly updated, so you can always get the latest version of the toolchain without having to install it on your system by using a Docker desktop. So you could just install Docker desktop on your Windows, Mac OS, or Linux machine and then just run a Rust container, or you could just even run it on a headless server just using the straight Docker engine as well. Or you could even use something like Podman if you wanted to run a container. Lots of different ways to get the Rust toolchain installed on your system or at least up and running. But the other tool that I wanted to mention that we're going to be using, of course, is Microsoft Visual Studio Code. So I did a video quite some time ago. I probably need to go back and update it, but it talks about kind of how to set up your entire development environment for Rust. And I typically just use VS Code because it's free, it's cross-platform. It has configuration synchronization with GitHub accounts, so you can just sign into it and it synchronizes across all the different systems that you're logging into, which is very convenient, especially when you're working cross-platform. Sometimes I switch back and forth between Mac OS and the Windows platform, so it's really nice to have that feature, or I should say configuration synchronization feature available. And there is, of course, the Rust Analyzer extension for VS Code as well. So if you just search for the Rust Analyzer extension out here, this is the extension for VS Code that allows you to get auto completion for Rust. It's really nice. It's very fast, at least on a decent hardware it is anyway, and it integrates very nicely with Visual Studio Code. So definitely check out the Rust Analyzer extension for VS Code, which you can install directly from the VS Code interface. You can also just do a Google search for Rust Analyzer VS Code Marketplace, and you can find it out there in the VS Code Marketplace, which is where it installs from if you are viewing it through VS Code. So yeah, you can just click on the install button from inside VS Code. That'll get the latest version of Rust Analyzer. Keep in mind that every time that you add new dependencies into your project, the Rust Analyzer does take a little bit of processing time to look at all the package metadata and make sure that it's able to do auto completion for macros, for enumerations, for structs, for traits, and all that kind of stuff. So it does take a little bit of time to work, but then once it's got all that metadata processed and loaded from the crates, it is pretty fast on most systems. So a lot of great tooling. One of the reasons I like writing Rust code is just because it has a really great tooling in the ecosystem, and it just makes it really easy to write code. One of the other recent tools I came across that I wanted to mention as well is the Grok platform from X or XAI. So the X platform has a built-in AI mechanism called Grok here. It's very similar to ChatGPT or Claude's from Anthropic or other similar models like Google Gemini and so on and so forth. But they just yesterday or the day before that, I think, released Grok 3, basically middle of February right now. And so Grok 3, it's currently in beta, but it is a pretty nice model. I had not actually really played around with Grok at all prior to the version 3 release, so I am pretty excited about it. It performs very well. It also gives really nice natural language responses as well, so definitely check out the new Grok 3 model. It is currently free as well for a certain period of time, but you can also sign up for it for, I think the rate is $30 a month. So you'll kind of have to think about, once the free tier is gone, if they decide to do that, then you'll just kind of have to make a determination if it's worth it. But it does have pretty good answers for software development. It's able to search across the web. It's able to do deep search, very deep, in-depth reasoning. So it's a really great platform for doing coding and just trying to understand different concepts from Rust and things like that. All right, so let's talk about the topic that we are going to be focusing on here, which is the clap crate. So the clap crate here, we are over on docs.rs, the official documentation site for Rust packages, or Rust crates, I should say. And there are, as I mentioned, two different approaches to building clap applications. So you can use the derive mechanism or the builder mechanism. I like the builder interface just because it gives you this fluent API where you can just do method chaining or function chaining. You can just call function upon function on itself and configure all of your command line arguments and commands and subcommands and all that kind of stuff. So that's a really nice way to do it. Not a super huge fan of the derive approach. I think it was kind of buggy before, so maybe I just need to give it another shot and see if it's any better now. What we're going to be focused on, though, is, as I mentioned, data validation. And before we actually talk about how to do the data validation, I wanted to talk about why data validation is important. So any kind of application you're building, whether it is a web-based user interface that you run in your browser, or if it's a native application that runs on Windows or Mac OS or that kind of thing, or if it's a command line application like what we're going to be building with the Rust clap crate here, the importance of data validation is really high up there, right? So anytime that a user is being prompted to provide some sort of input to your program, you want to make sure that the user has actually entered a valid input, a valid value into your program. Otherwise, if you don't do any validation, your program will experience unexpected behavior, which causes people to kind of lose trust in the application. It's, frustrating to deal with if they don't really know how to use it properly, if they're not getting feedback about invalid inputs and why it's invalid and how to feed in appropriate inputs, then they're not as likely to use your application, right? You can sometimes work around that with documentation, but if you actually do a lot more validation in code itself, it's going to provide a better user experience for whoever's consuming your application. So if you are, let's say, building an application that accepts, dates and times, for example, you might have a very specific format that you expect that date and time to be in. So you could do some validation against that data format. If you have somebody putting in like a first name parameter or a last name parameter, then you might want to make sure that the user is actually passing in a capital first letter, since that's proper English is to have like a capital T for Trevor, a capital J for Johnson, a capital Z for Zulu. But basically, there's a lot of different rules that we may want to implement to validate this data before we actually pass it into our application and then write it to a database or some other data store like that. So having that ability to do data validation in your code, especially early on when you're actually doing the command line parsing as early as possible inside of your application, that's really going to give you the most robust experience. So basically what we're doing is we're handing off all of this validation logic to the clap framework. And then we can, once we've validated that and all the command line parameters and arguments have checked out, then we can go ahead and actually start building out the business logic for our application. Some other examples might be like an age validation, like a numeric range. So let's say that you're building an application for, people that are 40 and over, for example. Well, if you have an age parameter or a date parameter or something like that, then you could calculate the person's age. And then if they're, within a certain range, or not within that range, you could either fail validation or succeed validation and then allow that value to be used. So that's another example where you might do a numeric or date-based type of parsing and validation as well. So there's a lot of different use cases. Another one as well would be to validate the existence of a file on the local file system. So if you take a string input parameter and say a user passes in file.txt, and your application is expecting that that file is going to exist as an input to your application. Maybe your application reads from that file and extracts some data and does some kind of processing on the data that's inside of that file. Well, it's going to be really important for you to validate that the file even exists on the file system, and maybe even go a step further to actually look at the file type and make sure that it is actually the file signature that you're looking for, especially if it's a binary data format that has some kind of header to it. You can look at those first few bytes of the file, validate the file header, and then if everything checks out and you've done some, basic sanity checks, then you can go ahead and move forward with building the rest of your application code. So, there's a lot of different things that you might want to do with validation, but the CLAP framework actually does have some of the validation capabilities built into it. If you drill under the builder module here, under the clap crate, so you go to clap root and then you go to the builder module, there are a variety of different data structures down here that are called value parsers. And these are what allow you to construct different types of validation mechanisms. So any of the structs here that end in parser, like string value parser or ranged I64 value parser or possible values parser or map value parser and things of that nature, or even just the non-empty string value parser. Just make sure I have a non-empty string, something really simple like that. That helps you to validate depending on what type of data is being fed in. So if you're doing something like age validation, you probably want to use a ranged unsigned 64-bit integer value parser. If you're going to do something like validation against a set of known values, then you might use the enumeration value parser, or you might use the possible values parser as well. Those are kind of two different options you have. If you already have an enumeration data structure, it might just be easier to integrate with that. But if you just have a static set of, string values that you want to validate against, you could use possible values here. And one of the cool things too is that you can actually build a custom function as a value parser as well, and then just pass that function in to the argument configuration, and that will allow you to do any kind of custom logic. So if you want to use, let's say, a regular expression crate to validate an email address, then you can build a regular expression, you can embed that in a custom validation function that you write, and then you can just hand off that validation function to the clap crate using what's called the value parser function on arguments, and then it'll do the validation for you. And anytime that you need to go update the rule to maybe fix a regular expression rule or something like that, you can just go to that function that's doing the validation, update that regular expression to ensure that you have a more robust validation mechanism. And then you're on your way, right? You don't really have to change any of your business logic because all of that validation is being handled inside of the CLAP supporting framework, right? So if we check out under the root of the clap crate here and then go down to structs and then go to arg, when you're building out an argument using the builder pattern that we talked about before, we've got all these different methods that we can call. So we can specify a short name for the argument. We can specify a long name for the argument. We can specify things like the value name, the help message. There's a lot of different things that we can do here. But one of the functions that is available, or I should say methods, if we scroll down in the list right here, is called the value parser method. And the value parser method basically takes this implementation of a into resettable trait with a value parser as a generic, which gives you a lot of flexibility. So remember, we talked about all these different value parser types under the builder module within the clap crate. And so we can use all these different ones or just build a generic function that allows us to do validation as well. So anytime that you see this value parser method being called on a new clap argument in the builder pattern here, that just means that validation is being done against these values here. So it's pretty easy to use. And so we're just going to kind of take a look at how to use it in practice. And then hopefully by the end of this video, you have a better understanding of how to implement your own custom validation logic in your applications that are using the clap crate. All right, so what we're going to do is fire up our VS Code editor here, and we're going to spin up a new project. So I'm going to head over to my Git project directory here. We'll go to cd/git. Also, I did want to point out, if we go over to the VS Code Marketplace here, I do have the Rust Analyzer installed here. Also, I've noticed people commenting on my videos asking about how I get the errors in line in the actual code editor, and that is an extension called Error Lens. So definitely check out the Error Lens package for VS Code. It's a really nice extension that just helps errors be a little bit more visible inside of your code directly. And then, of course, down here, wherever I get to R, I've got a lot of different extensions installed. As you can see, we should have the Rust Analyzer here. And this is updated on a really regular basis. I mean, they're constantly fixing issues here. So it was actually just recently updated today on February 20th. So it is really handy. It's very up to date and it's very reliable too. I've just had a really good experience with Rust Analyzer. So we'll open up the terminal here. We'll go to my Git directory and we'll just do a cargo new, and I'll say Rust YouTube clap data validation. And then I'll go ahead and do code and then do validation and open up that directory inside of my editor here. I guess it's going to open up a new window instead of opening up in the current window, which is totally fine. So now we have a new bare bones project here, nothing special. So we need to, of course, bring in the clap crate here. So we'll just do a cargo add clap, and that'll bring in the clap crate. If you want to use the derive approach, there is a optional derive feature down here, so feel free to add that, but I'm not going to be using the derive approach again. I know I've mentioned that a couple of times already. So now that we've got the clap crate installed, that's all we really need. So we'll go over to our source folder and open up main.rs right here, and we'll go ahead and start building out some examples. So for starters, I'm going to build out an example that just does really simple age validation. So let's say an age range from like 30 to 40 or maybe 25 to 40 or something like that. We want to validate somebody's age to, qualify them for whatever application we're building. Maybe we're running some kind of special event that's targeted to people who are in a particular age group or something like that. So we'll take a look at how to do just a really simple age validation for starters. So what we'll do here is we'll build a new function and we'll just call it age validator. And then we're going to go ahead and build out a simple command here. So we're going to go to clap command new, and then we're just going to call this base command. And then we'll assign that to a variable. So let cmd equal that. And then now that we have this command created, we can start appending arguments to it. But of course, we have to construct the arguments before we can add it to the actual command. So before we create the command, we'll go ahead and add in some arguments, or just one argument for now. So I'll call this age arg, and we'll do clap and then arg and then new. And we'll just call the arg age here, which is pretty self-explanatory. And then we'll do .long, and then we'll say age. That'll allow us to do --age anytime that we call our application. And you can also do a short one. So if you want to do short, you could do like just -a, for example. And that'll need to be in single quotes here because that is a character, not a string. So we can kind of configure out our argument here as we'd like to. We could add in a help message as well. So we'll say .help. This is the age that will be validated against. Cool. And then once we've got that, we can come down here and go to cmd.arg, and we'll go ahead and just append the age arg to our command. And what I'm actually going to do is just append that to the end of the command right there. And that way we are just doing all of this in a single line. And I'll go ahead and just add a new line there just so we can add a list of more parameters as we go on. Okay, so now we're going to talk about the validation mechanism. So what we can do here is add in another method on our builder pattern here, and we'll say dot value. And you can see we've got a few different methods here with a value prefix, but the one we're interested in is called value parser. So we'll go down to value parser here, and we'll go ahead and pass in a new parser. Now, there is a helper macro that I have not yet mentioned to you. At the root of the clap crate, there is a macro called value parser, and this will allow you to kind of automatically create a validator using any of the supported types. So as you can see, right here, we are creating a validator against an unsigned 16-bit integer, and then we're calling this range function on it, and we're specifying a range. So basically 3000 and larger than that are supported values for this particular parameter here. Also, if you wanted to validate against like a string set of values, possible values, you could use this option up here where you just pass in an array of string values. If you wanted to do non-empty, you could do this here. But let's go ahead and just use value parser, the macro, to check against a value, like a unsigned 16-bit integer, maybe even an 8-bit integer. We really don't need that much data for an age. So we'll go ahead and do clap, and then we'll do the value parser macro. We'll specify an unsigned 8-bit integer, and then we'll do dot range, and we'll say anybody who's 25 up to and including 40. So we'll say 25 dot dot equals 40. That's the inclusive range operator there. And so now if I pass in an age of 25 to 40, it'll work. If I go up to 41, it'll fail validation. If I go down to 24, it'll fail validation as well. So let's go ahead and test this out. But of course, I also need to call the function. So we'll call age validator from main. And then the other thing that we need to do, even though we've defined the argument and defined the command, we have to actually run the parser. So we'll do what's called a cmd dot, and there's a function here called get matches, and that'll do all the parsing for us. And so we'll say let result equal cmd.getMatches. That'll give us all of the matching arguments. And then down here, we'll say the age you passed in was placeholder, and then we'll go ahead and do result dot, and we'll just use the get one function. So result dot get one, and the ID of the argument that we want is the age argument, of course. And then that is wrapped in an option right here. So we're just going to go ahead and unwrap that value, and then we'll go ahead and close that off. Now you also see it says we need type annotations here. So it's not able to infer the data type of this argument right here. So what we should be able to do is use the turbofish syntax here to specify that this is an unsigned 8-bit integer. And as you can see, that cleans everything up. So now we have that type annotation. This is called the turbofish syntax right here. And then that will basically return an unsigned 8-bit integer. It'll unwrap it from the option enumeration type, and then it'll just pass it into this format string here. So let's go ahead and give this a try. We'll do a cargo run. And if we just do cargo run and don't pass in any parameters, let's see what happens here. So as you can see, it says we tried to do an unwrap on a none value because we did not pass in any value. So of course, we'd want to do some kind of data validation to make sure that unwrapping is not going to fail. So we would say if we could do a pattern match, we could also say if, results dot get one is not equal to nothing, then we can go ahead and just check that. But for now, I don't care about that. I'm not going to do the error handling. What I want to do is really look at doing the actual data validation itself. So what we'll do is do cargo run and then do dash dash. Anytime that you're using cargo run and then you want to pass parameters to your application, not to cargo itself, you need to put a dash dash because that will delimit the arguments that you're passing in, and it'll force those arguments after the dash dash to be passed to your application code rather than going to cargo and being interpreted by the cargo run command. So we'll do dash dash age, and then we'll do, how about 18 right here? And as you can see, it says invalid value. 18 is not in 25 to up to and including 40. So that's a pretty helpful error message that we got for free. We didn't even have to write that error message. We simply got that helpful error message solely due to the fact that we specified a range here for the value parser. So if we do, let's say 25, you can see that everything works perfectly fine. Validation passes and we get 25. If we try to go down to 24, once again, we're going to get an error here. Let's also try going up to 41. And as you can see, 41 is not within that range either. If we tried to do something like 41.5, it'll say invalid digit found in string. It can't parse 41.5 as an unsigned 8-bit integer. So that is also not valid input there. So as you can see, this is allowing us to put some constraints around the supported values for that particular parameter, just using a very simple unsigned 8-bit integer. Now, another use case that you might have is having some kind of categorization mechanism. So something else we might want to do is to, let's say we're selling different types of products, okay? And so we're going to do a type validator. You can call this whatever you want to. I'm just calling it a type validator because we're going to basically be checking against a few different types of products here. And so what we could do is create a list of different item types. So let's do let coat types equal an array, and we'll have a winter coat and we'll have a raincoat. And we could also do maybe a hoodie, just a lightweight hoodie. So there's going to be like 3 different types of coats that we might be selling in our store if we're building some kind of retail-based application here. And so what we want to do is ensure that when a user calls this application from the command line, that they are passing in one of these supported values here. And if we check out the documentation back over here, you can simply pass in this array into the value parser here, and it'll automatically figure out that those are the possible values that you want to validate against. So that's another nice way to do some categorization. Maybe if you're targeting different types of products, different departments, that kind of thing. Maybe you have different types of vehicles. You could have like truck, you could have car, you could have SUV, crossover, things of that nature. So if you want to check against a static list of categories, this is a great way to go. Okay, so to do this, we're going to go ahead and just do another command. So we'll just copy this command down here. And we are going to go ahead and create a new argument for coat types. And I'll just delete that age arg because we're not going to be using that anymore here. And then we'll do let coat arg equal. And then we're going to say clap arg. Sorry, let me get the arg struct there. And then we'll do new, and then we'll do coat dash type. That'll be the ID internally of the argument. And then we'll do dot long is going to be coat dash type. We'll just use the same one for long. And then we'll do dot value parser. And then this is where we're going to pass in our array. So we'll do coat types right here. And it looks like we don't want the borrow there. So we'll go ahead and just pass in our array directly. And so that's just an array of string slices here. So pretty simple, very easy to do. And so now down here, we'll go ahead and just add our coat arg to our command here. And then up here in our main function, we'll comment out age validator, and we will add the type validator. And then, of course, we also need to do get matches down here. So let's go ahead and just copy this code to do the parsing and bring it up here. And so after we parse, then we'll go ahead and say the coat type you requested was X. And then this time we're going to say result.get1. And this time we're going to parse it as a string value. And then we're going to do coat dash type. That's the internal identifier of the argument that we defined right here. And then we're going to unwrap that value from the option type. Cool. So now we'll test this out. We should be able to use any of these 3 values. And if we specify anything besides that, then it should fail validation. And one of the nice things is that because we have specified the supported categories right here, it's actually going to tell us what the valid values are if there is a validation error. So you kind of get that functionality for free thanks to the CLAP framework. So let's do a cargo run. And we should get an error, of course, because we did not pass in any value for that argument. So we'll do a cargo run dash dash, and then say dash dash coat type is rain. And as you can see, the coat type you requested was rain. Pretty straightforward. Works perfectly fine. If I do rain2, you can see that that fails validation right here. And it says invalid value rain2 for the coat type. So it's even telling us which argument had a validation error, and it told us what value was actually passed in by the user. So we could log that off to our application log somewhere so that we know what failed. But then it also tells us right here, here are the possible values. Here's the valid values that you can pass in for this. And one of the other even cool things down here is that it will find very similar items that are supported in the possible values right here. So rain2 was very close to rain, and it recognized that, so it recommended, oh, maybe you meant rain instead of rain2. So that's a really nice, just very nicely polished feature that I like about the clap crate. So again, rain works perfectly fine. If I do, how about a snow coat? Okay, well, that fails as well. If I try to do something like, how about winter with a capital W? That's going to fail as well because the case needs to match. So if we have a lowercase at the beginning for validation, then the value we pass in also needs to be lowercase. But of course, if you wanted to support upper or lowercase, you could write your own custom validator as well. But as you can see, doing a very simple age validation is simple against a range of values. Doing a comparison against a set of pre-known values is also very easy as well. All right, so the other thing I wanted to show you how to do is how to build an entirely custom value parser. And I don't remember if they have an example in here or not. I'm guessing they probably do somewhere, but it's actually really easy to write. So we're just going to take a look at how to do it. Basically, the function that you write for the custom value parser is just going to accept a string slice as input. And then the output will be, the output return value from that function is going to be a result type that either contains the result or an error. So pretty common pattern in Rust applications. So we'll go down to create clap here. We'll drill down to the builder module. We'll go to value parser here. Again, I'm just trying to see if they have an example or not for the custom value parser. I'm guessing they probably do, but that's where Grok can actually come into play. So if you go over to grok.com or just go to your X website and log into your X account, you can get access to Grok here. So let's see what Grok says, just for the heck of it. Not that I really need it, but it's an interesting exercise to go through just to see if we can learn from it so that we don't have to, hunt and peck through documentation. That's one of the great things about AI. It's kind of like a search engine for all this kind of randomly structured data out there. So rather than spending hours hunting and pecking through documentation, we can just ask it a very specific question and it goes out and finds all the information it needs and then it returns it to us. So how do I write a custom validator function using the clap crate for Rust? And I'm also going to specify the word argument. So how do I write a custom argument validator function using the clap crate for Rust? All right, so here is a really simple example. So it's function validate port. It takes the string slice as input. It returns that result type. In this case, they're just returning the unit type in Rust, and they're also returning a string as the error value. But then you can basically do whatever validation that you want to in here. And again, you can do regular expressions if you want to. You can do conversions on the data if you want to call like to lower to take uppercase and turn it all into lowercase and then do validation on all lowercase strings. You could do that as well. You could check if a file exists, like this example right down here, validate path. This is going to take the file path as a string slice input, and it's going to do path exists to determine if it exists or not. And if it doesn't exist, it'll return an error indicating that that does not exist. So it's pretty simple to write. And it's really up to you how complex you want to get. You could even do calls out to databases to do validation against databases before you decide to proceed if you want to. Obviously, that's going to have some performance implications if you're reaching out to network services. But again, if you need to write a robust application that has lots of data validation built in, this is definitely a mechanism that you want to look at. All right, so let's go ahead and build out a really simple example here. I'm going to use a first name as an example. So if we're building an application and we're, typing out a command to register a new user, then we might want to make sure that the user passes in a capital letter for the first name, just so that we have good data integrity inside of our database. We don't want some people using lowercase, some people using uppercase, and not really having consistency with our data set. So we can write this validation logic on the client side to ensure that data matches our desired rules. So what we'll do is create another validation function here. I'll call this name. Let's call it first name validator here. And I'm going to go ahead and create another function. So first name validator is going to be the actual validator, the custom logic that I want to build. And then I'll do another function here that just called first name. And then I'll call first name from our main function here. And then we'll build out our command in here. So first name validator is going to do the actual validation. Once again, we're just going to build a simple command. So I'll just copy that right up here. We're going to create a first name argument. So we'll say let first name arg equal clap and then arg new. And we'll just call it first dash name. And then we'll do dot long is going to be first dash name as well. We'll say dot help and say, please enter your first name with a capital letter. And then we'll do a dot value parser. And this time, when we call the value parser function here on our argument, what we're going to do is actually pass in this first name validator function. So we're just going to paste that in there. And then down here for the command, we're going to say add the first name arg to the command. And once again, we're going to call get matches to do the actual parsing. And then we'll go ahead and extract the first name. So the first name you entered was X. And then we'll go ahead and pass in the first name value here as a string. And that looks all good. Okay, so now we need to fill out the first name validator function here. As you can see, when we call value parser and we pass in a reference to first name validator function, it's giving us an error. The Rust compiler is throwing an error because the validator function is expected to take a single argument. So down here in our function signature, we need to specify our input value. So we'll do value and then string slice. So now that takes care of the input. And then you can see we get a different compiler error here because the first name validator function needs to be a function that returns the result type. So right now, as it currently stands, we are returning the unit type implicitly from the first name validator function. That's why it says, but it returns unit type in Rust. But we need to go ahead and force it to return the result type. So that could be okay, or it could be an error. So up in our function signature here, we'll do an arrow and we'll say, give me a result. And for the error type here, I'm going to use standard IO error right here. And that'll allow us to return a custom error with a custom message. I'll show you that in a second. But then for the actual result, I'll go ahead and just return the unit type right here. And then down here, we'll go ahead and just say return the unit type. And then up here, we're going to actually run our validation logic. And of course, this needs to be okay. Sorry. We need to do okay unit type there. And I sometimes like to use return with the semicolon at the end. You don't have to do that, but I kind of like to do that. I know that's not technically the Rusty way of doing it. The Rusty way of doing it is just to leave return off and leave the semicolon off, and that will just take this final line in the function and return that value from the function. But it's up to you how you want to do it. I guess I'll leave it the rusty way now that I did that. So what we want to do is basically take this value as input and do some validation against it. So to do this, what I'm going to do is bring in the regex crate. So we'll say cargo add regex so we can use regular expressions. And then after Rust Analyzer finishes analyzing the regex crate, then we'll go ahead and create a regex. So I'll say let first name regex equal regex new. And then the regular expression that we want to compile here, we'll use the capital A to capital Z character class in square brackets. And then we'll do /w for word characters. And we actually need to do a double slash there because otherwise that's going to escape the string in Rust. And then we'll put a plus sign indicating that any number of word characters after the initial capital word character is going to be just fine. Okay, so we'll create that regular expression, and then we'll say if the first name regex dot, and then, sorry, we have to unwrap this here as well. So the reason we get a result type from the regular expression is because if for some reason the regular expression string that we passed in here did not validate correctly, if it's not a valid regular expression, then we would get an error trying to compile that regex. But I'm just going to go ahead and cheat and just do .unwrap here. Or you could also do .expect and say, you wrote an invalid regex, please fix it. That's another pattern you can do as well, is to add on expect there. And then you know exactly what's failing if your application fails for some reason. So we'll say if the first name regex dot is match, and then what do we want to match against? Well, we want to check the value that's being fed into the validator function to see if it matches the regular expression that we wrote right here. So we're just going to pass in value right there. That's our function input. And then if it does match, then we can return OK. Otherwise, if it does not match, then we'll go ahead and return error. And in this case, we are going to actually need to return explicitly here. So we'll do return. And then down here, we are going to create a new standard IO error. And we'll go ahead and do new. And this takes an error kind, and we can use the other error kind on that enumeration. And then we can pass in a string as our custom error message as well, so that we know exactly which validator is failing here. So we'll say new, and then we'll do error kind of other. Let's do error kind and import that, and then we'll do other. And then for our error message here, we'll say, please make sure first name is capitalized. Okay, so if we get a validator error, we should throw this. You can choose other types of error message structures as well, but I'm just going to use the built-in one from the standard IO module. Okay, so I think we have everything wired up correctly. We're calling first name from main. We are defining our argument. We're passing in first name validator as the value parser. That's the important bit to do the custom validator function right here. We're adding that argument to our command, parsing, and then we are printing out the result. Okay, so let's go ahead and give this a try. We'll do a cargo run. And if we don't pass anything in, it'll probably fail, as we've seen before. Okay, so it does fail. That's fine. And then we'll do first dash name, and we'll specify how about lowercase Trevor. And as you can see, that failed. And right down here, it says, please make sure the first name is capitalized. That is coming from our custom standard IO error right here. And then it tells us, hey, here's the value that you actually passed in, and here's the error message for why it actually failed. So if we try something else, like capital T Trevor, then you can see, looks like that is failing as well. And so it's saying it cannot downcast to a string right here. So I think what we need to do is to change the type that we are parsing out right here. I think we need to make that a string slice instead of a heap allocated string. So let's go ahead and try that. And it looks like that is not working either. So let's go check out line number 21 where it is failing right here. And oh, I changed it in the wrong spot. Silly me. Let's change this to a string slice up here. That's the correct one. I think I changed it down here. This is the type validator that we were doing for coats. So let me change that one back to string, just so we don't run into any issues there. So let's go ahead and try to execute it again. And it looks like it is failing here once again. So let me try removing the generic type here altogether, and we'll just do get one, although it does say type annotations are needed in that case, but of course I'm editing the wrong one again. Let's come up here and see if we can remove that type annotation, and it doesn't like that. So we're passing in first name. That looks fine. Let's see what else we've got here. And of course, I made a pretty bad error here. So the value that we return here needs to not be the unit type. We actually need to return the string value. So when we return a string value that's been validated or potentially even altered, then what we need to do is say, all right, take that value and turn it into a heap allocated string. So your return type needs to be the data type that you're actually returning. I don't know why I was thinking to put the unit type in there, but we need to then actually return the result type, which is okay, and then pass in the value that we want to return back to the caller. So that should definitely work. Not sure why I overlooked that there. So it looks like we are still getting this error here, and I'm guessing that's probably because we changed the type that was being cast here, and that needs to be a heap allocated string here as well in that turbofish syntax. So let's give that a shot here. And as you can see, that does work perfectly fine. Okay, so as long as you get the function signature correct and you've got your correct type here for the downcast, that is going to work just fine. And then if we try this with something else like lowercase t, once again, we can see that that fails validation. That's good. Let's try something else like James. As you can see, James with a capital J works fine. If we do a lowercase j, that fails as well. And then if we try something that's bizarre, like maybe putting a number at the beginning, you can see that that fails as well. So what we might want to do is actually improve our error message here and say, please make sure the first name is capitalized and make sure that you're not using a leading special character or number or anything like that. So our error message could probably be improved here, but you get the idea. If we do any invalid input here that's not a capital letter from A to Z, then it is going to fail validation. So again, you could use this custom validator function that we wrote right here to do pretty much any type of validation that you want to. If you want to validate a file path or something of that nature, that would be a good place to put it as well. And again, if you want to call out to a database or something in here, call out to a MySQL database or a cloud-hosted, MongoDB database or Amazon DynamoDB database or something, and validate against a set of known data inside of that database, you could do that in here as well. You could even validate from a list of items that maybe you have stored in a local JSON configuration file. So you could read the JSON configuration file, load that in, and then do some custom validation against those items as well. It's really up to you how fancy you want to get with it, but this is the signature that you would use to build a custom validator function here. So anyways, those are some of the core data types that we can use to do validation here. We looked at doing the range-based validation right down here. We also took a look at how to do a possible values validation right here against a set of pre-known values. And we finally looked at how to do custom validation here as well. So hopefully this satisfies the needs of the viewer that left a comment earlier on doing the clap argument validation. Sorry, I totally missed that in the last video that I did on the clap crate, but hopefully this gives you a better understanding of how to do validation. Anyway, thanks so much for watching. I apologize it's been so long since I've done a Rust video, but I really do love Rust, and I wanted to get another video out that covered this topic since somebody did specifically request it. If you did learn anything new, please leave a like on the video. That helps me grow my channel and bring you free content. Also, please subscribe to the channel and leave a comment down below below and let me know what other topics you're interested in and what you learned from this video. Thanks again, and we'll see you in the next video. Take care.